In this video, we are going to practice various transformations like reflections, rotations, and also dilations and translations. So we're going to do a little bit of everything. But you see these rules on the screen? You have to have these memorized. Your reflection rules and your rotation rules. So if you do not have these memorized yet, I need you to pause the screen right now and write them down and study them. Here are your reflection rules. Here are your rotation rules. Okay, so let's practice. Let's see if you can remember these. Try to do this without looking back at the other screen. Let us begin with the reflections and rotations that we just looked at on the other screen. Let's see. Opposite of x, y, that is a reflection over the y-axis. Opposite of y, opposite of x. That's a reflection over the line y equals negative x. And all I'm doing is I'm copying off of this sheet right here. Okay, so you see this opposite of y, opposite of x. Oh, that's a reflection over the line y equals negative x. So I'm assuming that you have these memorized, and that's how we are labeling all of these. Yx, that's a reflection over the line y equals x. X opposite of y, that's a reflection over the x-axis. All right, now let's talk rotations. Opposite of x, opposite of y, that is a 180-degree rotation. Y opposite of x, that is a 90-degree clockwise rotation. And opposite of yx, that is a 90-degree counterclockwise rotation. All right, so those are the ones on the chart. Those are the ones you really have to memorize. Now, these other ones are more common sense. Y minus a number, that's going to move you down that much, okay? The y values control up and down motion. So this would be down by whatever the number is. If you add a number to the x value, that's moving you to the right by that number. If you're adding a number to the y value, that's going to move you up by that number. If you're subtracting from the x value, that's going to move you to the left by that number. And dilations or stretches or shrinks. So if you multiply the x and the y, that's when you have a dilation. And so if the number is bigger than 1, it's going to grow. And if the number is less than 1, it's going to reduce. If you're only multiplying the x value, that's going to be a horizontal stretch or shrink. All right, depending on whether or not the number is bigger than 1 or less than 1. But multiplying the x is a horizontal change. Multiplying the y value, that is a vertical change. So this is going to be a vertical stretch or shrink. All right. So now let's see if we can use these. Oh, okay. Underneath each one, okay. So this was like a word bank that I didn't realize that we had. But there you go. We nailed it. All right, moving on to the actual problems. Write the algebraic rule for each transformation. You need to know these by heart. So left 1, down 4. That would be x minus 1, y minus 4. Write 3 down 2. So write 3, that would be x plus 3. Down 2 would be y minus 2. Reflection across the x-axis. That is going to be x opposite of y. I'm just copying off the chart, people. Copying off the chart. Well, in my mind. Because I have it memorized, and so should you. Reflect across the y-axis. That's going to be opposite of x, comma, y. Reflect across the line y equals x. That's yx. Reflect across the line y equals negative x. That is opposite of y, opposite of x. 90 degrees clockwise, you say. That is going to be y opposite of x. 90 degrees counterclockwise is going to be opposite of y, comma, x. And a 180 degree rotation is opposite of x, opposite of y. All right, so this would be a good set to practice over and over again until you can get these right 100% of the time. Dilating from the origin by a scale factor of 3. Again, a dilation means you're going to do both the x and the y. So that's why it's going to be 3x, 3y. So whenever you see dilation, it's going to be both. If it's going to be horizontal, that's just going to be the x value. If it's going to be vertical, that's just going to be the y value. So horizontal stretch only. So that would be 3 times x, and the y stays the same. A vertical stretch, that makes it 3 times as tall, is going to be, the x will stay the same, and we'll multiply 3 times the y value. So again, x is horizontal, y is vertical. Problem number 2. Point A is located at 8, negative 5. Find the coordinates of A prime after each transformation. Right 5 and up 3. So right 5, so that's going to be plus 5. And up 3 is going to be plus 3. So that's going to give us 13, comma, negative 2. All right, I'm just combining these like terms, if you will. I think I'll switch colors in between each problem so you don't get confused. Translate left 10. We're only moving to the left, so I'm going to subtract 10 from the x value. I'm going to leave the y value alone. Negative 10 and 8 is negative 2, so that's negative 2, negative 5. Okay, reflect across the y-axis. Remember, the rule for this is going to be opposite of x, comma, y. So the opposite of x is negative 8, and y is negative 5. Reflecting across the line y equals x, the rule for that is y, x. Y is negative 5, and x is 8. Reflect across the line y equals negative x. So the rule for that is opposite of y, opposite of x. The opposite of y is positive 5, and the opposite of x is negative 8. By the way, notice I don't say negative y or negative x. I say the opposite of y and the opposite of x. That's because if you get in the habit of saying negative y, it's going to make you think that it has to be a negative number. But notice it's not. It's a positive number. Even though there's a negative here, there's a positive in the answer. That's because when it comes to these formulas, a negative sign here really means the opposite. So if it was already negative, you have to make it positive. So I recommend being like me. And in fact, in most ways, that's just a good idea. Be like me. You listening, Maya? Be like me.
Okay.
That's my daughter. I always try to get her to follow in my footsteps and stuff.
It's true.
So let's see. Rotating 90 degrees clockwise, that's going to be y opposite of x. Y is -5. The opposite of x is -8. Okay. Rotating 180 degrees, that is opposite of x, opposite of y. So opposite of x is -8. The opposite of y is +5. Okay, now we're dilating by a scale factor of 3/2. Remember, when you talk dilation, you're going to do both. All right, we're doing the x and the y. So that's going to be, well, you know, I feel like we need to do a little scratch work here. I need to do 3/2 times 8 and 3/2 times -5. So that's what I'm about to do. So I'm going to do 3/2 times 8, and I'm going to do 3/2 times -5. Now, this 8 is like 8/1, and -5 is like -5/1. So this is going to become 24/2 and -15/2. But 24 divided by 2 is 12. So this is going to be 12. -15 divided by 2 is -7.5. So that is the answer. All right, draw the image and write an algebraic rule for the transformation. Don't forget to label the vertices. So we're going to translate left 2 and down 7. So we could do this visually. So if I take F and I move left 2, and then down 7. So it's 2, 4, 6, 7. All right, I'll do the same thing with G. Left 2, down 7. All right, same thing with E. Left 2, and that's down 4, 5, 6, 7. So this will be F prime and G prime and E prime. Brilliant. I'm just going to connect these dots real quick. Please stand by. Ooh, that's a white line. That's not what I wanted. Okay, and the rule. So left 2 and down 7. That should be x minus 2 and y minus 7. Reflecting across the x-axis. So here's the x-axis right here, x-axis. In fact, sometimes I like to draw the mirror line in blue. So that's what I'm going to do. So here is the reflection line right here. You know what? That's garbage. Let's use the line tool. Okay, so here is the mirror line, the reflection line shown in blue. So F is 2 above, so F prime will be 2 below. G is 2 above, G prime will be 2 below. E is 4 units above, so E prime will be 4 units below. So here is your reflection over the x-axis, and this is F prime and G prime. Don't forget your labeling. And E prime. All right, let's see if I can have better luck drawing these lines than I did last time. almost stopped the video and did it over again. But you know what? It's nighttime. It's like 8 o'clock at night. I don't have time for that mess. Okay. You know what? Lock drawing mode. That's what I need. All right, that's what was messing me up. Now we're good. And when you are reflecting across the x-axis, we know that the rule is x opposite of y. Because we memorized that, right, people? Of course we did. Reflecting across the line, y equals negative x. I think I'm going to write the rule first because I'm going to actually use the rule this time. So the rule for this is opposite of y, opposite of x. So let's start by writing down the original coordinates of E, F, and G. So point E is going to be 2, 4. And point F is negative 2, 2. And G is 3, 2. All right, now let's go ahead and find E prime and F prime and G prime. Okay, so remember we're doing opposite of opposite of y, opposite of x. So the opposite of y is negative 4, and the opposite of x is negative 2. The opposite of y is negative 2, and the opposite of x is positive 2. The opposite of y is negative 2, and the opposite of x is negative 3. All right, so negative 4 and negative 2 is going to be right here. So that's going to be E prime. Negative 2, positive 2 is going to be right here. So that'll be F prime. And then negative 2, negative 3 is going to be right here. All right, so this was E prime, F prime, and G prime. Let's draw those lines. Okay, now remember that the line y equals negative x is a diagonal line that goes downhill. So this is the line y equals negative x. It's helpful to know that just to mentally check your work because these two images should be mirror images of each other across this line. And you can see that they are, so you know that you did it right. Okay, let's move on to number 6. So now we're going to do a 180-degree rotation around the origin. All right, so these are the same 3 points. So we still have 2, 4, and point F is negative 2, 2, and point G is 3, 2. The rule, 180-degree rotation. We know the rule is going to be opposite of x, opposite of y. So that is what I am about to do. So that means E prime is going to be negative 2, negative 4. All right, opposite of x, opposite of y. F prime is going to be positive 2, negative 2. And G prime is going to be negative 3, negative 2. So let's see, -2, -4 would be right here. +2, -2 would be right here. And -3, -2 would be right here. Okay, so this was E prime, F prime, and G prime. Ooh, I meant for that to be red. Will it be good, honey?
I have.
Do you?
No, I have one more thing, but I'm going to do that on tomorrow.
All right, you know you're in this video right now.
Oh shoot!
All right.
Sorry.
That's all right. You're spicing up the video with your talk of Romeo and Juliet in the middle of this math. But that's it. So that's how you do a 180-degree rotation. Okay, so number 7, 90 degrees clockwise. So we know the rule for that is going to be y opposite of x. All right, we're still using these same points as before. So we're still doing E is 2, 4. And F is -2, 2. And G is 3, 2. So we're just going to use this rule just like we did before. So let's find E prime, y opposite of x. So that's going to be 4 and then -2. All right, how about F prime? Y is 2. The opposite of x is +2. Now G prime. Y is 2. The opposite of x is -3. So 4, -2. And 2, 2. And 2, -3. All right, so that is E prime, F prime, and G prime. All right, and so there you have it, a 90-degree clockwise rotation around the origin. All right, time to do a dilation by a scale factor of 3/2. 3/2 is bigger than 1. I can tell because the numerator is bigger than the denominator. Also, I know that 3/2 is the same thing as 1.5. Anyway, when the scale factor is bigger than 1, this should be an enlargement. So I'm looking for the triangle to get a little bit bigger. So let's see that happens. When you do a dilation, it's going to affect both the x and the y. So that means, as far as a rule goes, I need to do 3/2 times the x value, and I need to do 3/2 times every y value. Okay. So again, I'm going to start off with the original points that we've been doing this whole time. So point E is 2, 4, and point F. All right, I feel like I'm going to need more space this time. All right, I'm gonna leave space under each one of these. So point E, and I'm going to put point F over here, which is -2, 2, and then point G I'm going to have to go off the page a little bit, which I don't like to do, but I'm going to do it anyway. It's 3 comma 2. I need space because we have to multiply by 3 over 2. And I don't have my calculator right now, so we're just going to do it by hand. But it may take a few steps. All right, so here we go. So if I want to do E prime, and you know what, maybe I'll just zoom right on in here. So if I want to do E prime, remember I'm multiplying everything by 3 over 2. So that means I need to do 3 over 2 times 2, and I need to do 3 over 2 times 4. So if you have a calculator handy, you can just multiply these on your calculator if you need to. Or you can use your brain and do it by hand. So these are, 2 is like 2 over 1, 4 is 4 over 1. So this will make 6 over 2 and 12 over 2. But that means that E prime is going to be 3 comma 6. Okay, maybe I'll just go ahead and plot that right now. So 3 comma 6 is going to be up here. Kabam. So that's going to be E prime. All right, let's switch over to F. So F prime is going to be 3 over 2 times negative 2 and 3 over 2 times 2. Okay, so F prime. So we already found that 3 over 2 times 2 turns out to be 3. So we already know that this is going to be 3. So the only difference is this one is negative, so that means that's going to be negative 3. So we don't have to go through all of the steps. All right, we can do a couple of shortcuts. So let's see, negative 3 comma 3 would be right here. So that is going to be F prime. Okay, now it's time for G prime. All right, so we're going to do 3 over 2 times 3 and 3 over 2 times 2. Again, we already know that 3 over 2 times 2 is 3. By the way, another way we could have done 3 over 2 times 2 is these 2's cancel each other out. And that's another reason why you know it's going to be 3. So I'm going to go ahead and put comma 3. Now this part, I'm going to do this again. So this is going to be 9 over 2. But 9 over 2, 9 divided by 2 is 4.5. So this is going to be 4.5 comma 3. So that is going to be my G prime, 4.5 comma 3. Okay, so let's see, 4.5 comma 3 is going to be right here. And that's it. So that'll be G prime. And now let's just connect those lines. And that's it for number 8. For problem number 9, we have to reflect the line, we have to reflect across the line y equals 1. Now, remember, when you have an equation of the form y equals something, this is actually a horizontal line. Even though the y-axis is vertical, y equals 1 is actually a horizontal line. I like to draw these in blue for some reason. All right, so this is the line y equals 1 right here. So let's just graph this visually. L is 1 above the line, so L prime will be 1 below. K is 1 above, K prime will be 1 below. J is 1, 2, 3, 4 above, so J prime will be 1, 2, 3, 4 below. All right, so this is K prime, L prime, and J prime. And we just draw the lines. Okay, I meant for that to be red now. All right, so there we have a nice reflection over the line y equals 1. The most important part is that this is a horizontal line. On the other hand, the line x equals 1 is actually a vertical line. All right, so if you get that wrong, obviously your whole picture is going to be wrong. So make sure you have that straight. X equals a number is vertical. So this is the line x equals 1 right here. So again, I'll do this visually. K is 2 units to the left, so K prime will be 2 to the right. L is 5 units to the left, so L prime will be 5 units to the right. And J is 5 units to the left, so J prime will be 5 units to the right. So here I have K prime, L prime, and J prime. I have a feeling this is going to be a blue line again. Let me fix that. Ahead of time for once. Okay. Number 11. Reflect across the x-axis and then rotate 90 degrees clockwise around the origin. Okay, all right, so you're only required to draw the final image, but it might also be helpful to draw the other thing. All right, look, I'm going to do the reflection over the x-axis visually, as you've seen me do before. So my reflection over the x-axis is going to look like this. So L is 2 above, so L prime will be 2 below. And then J is 5 units above, so I'm going to go 5 units below. K is 2 above, so here I am 2 below. So this is J prime, K prime, and L prime. All right, so this is what it looks like after the first transformation, after the reflection over the x-axis. All right, let me just record those labels. So this is L prime, and this is K prime, and this is J prime. So I've done the reflection. Now I'm supposed to take this. I'm not going to go back to the original triangle. I'm supposed to rotate J prime, K prime, and L prime 90 degrees clockwise around the origin. So that's what I'm going to do right now. So I think it will help to have the coordinates written down. So J prime is -4, comma, -5. So let's write that down. So J prime is -4, -5. And then K prime is -1, -2. And L prime is -4, -2. All right, so now it's time to do the 90-degree clockwise rotation. We know the rule for that is y opposite of x. So that tells me that j double prime is going to be y opposite of x. So y is -5, and then the opposite of x is +4. All right, and same thing for k double prime, y opposite of x, so y is -2, and the opposite of x is +1. And we'll do the same thing one more time for L double prime. Again, y opposite of x. Y is -2. The opposite of x is +4. So this is really going to be the final answer. So -5, 4. All right, so -5, 4 would be right here. -2, 1 would be right here. And -2, 4 would be right here. Okay, so I'm just going to connect those dots real quick. All right, so this is the image that's rotated 90 degrees clockwise. Now I do need to label these. So this was J double prime right here, and this is going to be K double prime, and this is L double prime. All right, and that's the final answer. So the final answer is the red shape. So let's do that again with problem number 12. So first we're going to rotate 90 degrees clockwise around the origin. All right, let me get over here. So when I do 90 degrees clockwise, I use the rule. So the rule is y opposite of x, like you just saw on problem number 11. Let's go ahead and write down the original coordinates. All right, so for point J, that's -4, 5. And then point K is -1, 2. And then L is -4, 2. Okay. So I'm going to do this 90-degree clockwise. I'm going to do y opposite of x. So that means J prime is going to be 5, 4. All right, that's y and the opposite of x. K prime, y is 2. The opposite of x is 1. And then L prime, y is 2. And the opposite of x is 4. All right, let's go ahead and graph that. So 5, 4 is going to be right here. So that's going to be my J prime. 2, 1 is going to be right here. So that's going to be my K prime. And 2, 4 is going to be right here. And that's going to be my L prime. All right, so give me a second to connect those dots. All right, so that's what we're looking like after the first transformation, after this 90-degree clockwise rotation. But now we are supposed to reflect the purple triangle, J prime, K prime, L prime, across the x-axis. So if I do this visually, so K prime is 1 above, so K double prime will be 1 below. So here I have K double prime. L prime is 4 above, so L double prime will be 4 below. And similarly, J prime is 4 above, so J double prime will be 4 below. And give me a second to connect those dots. All right, so there is the reflection over the x-axis, so this will be the final answer. All right, number 13. Circle the transformations that would map this triangle onto itself. So mapping something onto itself, especially if you're talking about reflections, and all of these are reflections, we are actually looking for lines of symmetry. So let me switch over to my blue color, because that's what I like to use when I'm drawing lines of symmetry. I'm looking for a line that would split this triangle right down the middle, all right, like a mirror. And it looks like this line right here. Do you see how that line splits this triangle into two identical halves? But the name of this line is the line y equals x. So that means that if I reflect over the line y equals x, that will map the triangle back onto itself. Now, that's the only line that I see that is a line of symmetry for this particular triangle. So I think that's going to be it. The line x equals 3 would be a vertical line. At 3, that's not a line of symmetry. The x-axis doesn't even pass through the triangle, so that's no good. The y-axis doesn't go through the triangle either, so that's the only one. All right, let's look at number 14. Fill in the blanks to describe the transformations that would map the rectangle onto itself. All right, let's use the same thought process. Let's look for lines of symmetry. I see 2 lines of symmetry for this rectangle. This is a line of symmetry. See how it splits the rectangle into 2 equal halves, 3 units below and 3 units above. But this is the line y equals -1. Remember that a horizontal line is of the form y equals. All right, so y equals -1. All right, that is one line of symmetry, so reflecting across that line will map the rectangle onto itself. But there is another line of symmetry. I feel like I should pick a different color just this once. Maybe green. All right, because I'm leaving both of these visible at the same time. So take a look at this one. Okay, so this would be another line of symmetry. And again, you can see how it splits the rectangle right down the middle. Vertical lines are of the form x equals something. So this vertical line is the line x equals 3. So reflecting over the line x equals 3 will map the rectangle back onto itself. Okay. Each row describes a transformation. Complete each row. You're given one piece of information in each row. and that is indicated with a box. All right, looks like I have to zoom out a little bit. Okay, so for number 15, we are given the graph. So let's see what is going on here. This is going to be a rotation. All right, you can tell it's not a translation. It's not a slide, because do you see how the letters don't quite line up? The B prime is high and the B is low. So this is only going to happen if this is rotated. That's what's sort of flipping it upside down. So this would be a 180-degree rotation because of the way it's flipping completely upside down. So, we are rotating 180 degrees around the origin. I guess they even gave us a hint. They told us it was a rotation. So it's just a matter of, was it 90 degrees or 180? But it's a clear across the graph. It's totally upside down. That's 180 degrees. We know the rule for that is opposite of x, opposite of y. We've memorized that. So using that rule on these points right here, the opposite of x is going to be -2. The opposite of y is -1. The opposite of x is -3. The opposite of y is +2. Okay, so we're looking at a reflection here, and I think it's obvious that the reflection line is right here. See how this line forms a mirror image between the two? And that is the y-axis. All right, reflection across the y-axis. And the rule for that is opposite of x, comma, y. And look, I could use the rule to get the a prime and the b prime, or I could just look at the graph. I could have done that up here as well. I could have looked at the graph for a prime and b prime. So I think I'm going to do it that way this time. A prime is at -2, 1. So let's use that, -2, 1. And yeah, you see it is the opposite of x and y. B prime is at -3, -2. And yes, you see it is the opposite of x, comma, y. Opposite of x, comma, y. So we have another reflection. Oh, this time they gave us the rule. Opposite of y, opposite of x. So that is the reflection over the line y equals -x. All right, we've memorized that. So let's use the rule to get the points that we need. Opposite of y is going to be -1. And the opposite of x is going to be -2. The opposite of y will be +2, and the opposite of x will be -3. So -1, -2. That's going to be right here. And 2, -3. That's going to be right here. So this is a prime and b prime. All right, so that's going to be like this. Now, remember, the line y equals -x is a diagonal line that's going downhill right through the middle of the graph. So just remember that to check your answer, because you can see that the black segment and the red segment are in fact mirror images of each other over this line. So it's always good to double check that. Okay, and we're almost to the end. Okay, these ones are the trickiest. Let me zoom in on this a little bit. It's the trickiest when they give us the ordered pairs, and we have to work backwards to figure out what the rule was. They gave us an important hint that we do not want to overlook, though. Let's look back at the beginning of the question. See how they say translate blank. So we know it's going to be a translation. So let's look for that. Let's use that to our advantage. So the x value is going from 2, all right, looking at the a and the a prime, we're going from 2 to -4. So obviously it is decreasing, but it's decreasing by how much? Well, let's see. If I did 2 minus 6, that would be -4. So it looks like we're subtracting 6 from the x value. What about the y value? All right, the y value is going from 1 to 3. That is increasing, so that looks like we're adding 2, so plus 2. So this is my guess. This is my hypothesis. It seems like we're doing x values minus 6 and y values plus 2. Now, let's use point B to test that out. So if I take 3 and I subtract 6, which is what our rule is saying, that is going to give me -3. If I take my y value and I add 2, oh, look at that. -2 plus 2 is, in fact, 0. So we can be confident that this is the rule. Now, they gave us a prime and b prime, so graphing is going to be super easy, barely an inconvenience. A prime is -4, 3. So -4, 3 is going to be right here. B prime is -3, 0. They just flat out gave it to us. So -3, 0 is going to be right here. In fact, now that I think about it, that's another way we could have done this problem, is to just graph the points first. So, all right, so this is A prime and this is B prime. So we could have done this. We could have graphed the points first, and then we could have asked ourselves, wait a minute, how do we get from A to A prime? And you can see to get from A to A prime, you would have to go left 6, and then up 2. So that's -6, x minus 6, and y plus 2. So that's another way you could have done it. That might even be easier. All right. Oh yeah, we still have to do the translation. So we will go ahead and now say left 6, up 2. All right, number 19. We need to shrink vertically by a scale factor of 3/4. So as soon as you see vertically, you know that's going to be a change with the y value, only the y value. Okay, so that means we're going to leave the x alone, and the y value will become 3/4 of whatever it was. So let's jump over and do that. So the x values are staying the same, people. I think I'm going to use a finer pen for a second. All right, the x value is staying the same. So that means for C prime, we're going to stick with the -2, and we're going to stick with the 4. All right, however, we have to multiply the y value by 3/4. So off to the side here, I'm going to do 3/4 times 4. Now the quickest thing to do is just to cancel these 4's out, and you immediately see it's going to be a 3. The slightly longer way is to go, okay, this is 4/1. 3 times 4 is 12. 4 times 1 is 4. 12 divided by 4 is 3. All right, that gets you the same answer, but it's a lot quicker just to realize that these will cancel out. Now, if I do the same thing with -4, I'm just going to get -3 instead of +3. So that's it. So now I have C prime and D prime. All right, so I'm going to graph these now. Okay, negative 2 comma 3 is right here. So that's going to be C prime. And 4 comma negative 3. All right. Yeah, so this is 4. Negative 3 is going to be right here. And that is going to be D prime. All right, so that is the final answer. So you can see that horizontally, the picture did not change. The x values are the same. It just got a little bit shorter because of the y values. All right, we're down to the last one. Look at the rule, 1/2 x, 1/2 y. When you have the x value and the y value changing, that is a dilation. So we will remember that when it's time to do the description, that this is a dilation with a scale factor of 1/2. So the rule tells us exactly what to do. So we just need to multiply the x's and the y's by 1/2. So I think I'm going to do that kind of off to the side a little bit. So I need to do 1/2 times negative 2, and I need to do 1/2 times 4. Half of 2 is 1, so this will be negative 1. Half of 4 is 2, so we will have negative 1 comma 2. All right, similarly, half of 4 is 2, and half of negative 4 is negative 2. So we can easily plot these points. Negative 1 comma 2 is going to be right here. And negative 2 comma negative 2 is going to be right here. So this will be C prime and D prime. All right, so you can probably see that the line became half the size that it was before. And that was a dilation from the origin by a scale factor of 1/2.